Hi, welcome to my channel Programming in C with RSK, and I am Rajendra Kulkarni. Friends, in this video we are going to discuss about the 3D arrays with examples. So this is a video where there will be introduction to 3D arrays. So let us start with a slide how to declare a 3D array and how to initialize it. And what is a 3D array? 3D array is a three-dimensional array of two-dimensional arrays as its elements. So 3D array has 2D arrays as its elements. Its declaration and initialization we are seeing in this figure. We have declared an array ARR with 3 subscripts. First subscript is 2, second one is 5, and third one is 2 again. And we can see there are two 2D arrays we have assigned to this 3D array. Watch carefully how we have written the initialization. This is the opening brace and this is the closing brace of the 3D array initialization code. Within these two opening and closing braces, there are the two braces again in which we have written the elements or the constants which will be forming elements of this 3D array. So array 0 0 or 0th element of the 3D array is a 2D array consisting of constants of type int 1 2 3 4 5 6 7 8 and 9 10. So this 2D array has 5 1D array as its elements, and each 1D array has 2 constants as its elements. Similarly, this is the element number 1. If we call this is the 0th element, then this is the element number 1 of the 3D array ARR. In this element also there are 5 2D arrays, each with 5 1D arrays, each with 2 constants, int constants as its elements. First subscript 2, this subscript, it indicates that the 3D array will contain 2 numbers of 2D array as its elements. Second subscript, which is 5 in our case, indicates that each 2D array is of 5 1D arrays. So there are 5 1D arrays as its elements of the 2D arrays. Third subscript tells the compiler that each 1D array has 2 elements. All the elements of the 3D array are allocated contiguous memory locations. Conceptually, we can visualize a 3-dimensional array as a workbook. Let me explain it in details here. A workbook of multiple sheets. The first subscript telling the number of sheets in the workbook. Friend, this is only a conceptual visualization. Second and third subscript can be visualized as a table on each sheet. Second subscript is the number of rows in the table and third subscript is the number of columns of the table. So when we declare an array as int ARR 5, 7 and 10 as its subscripts, we can visualize it as 5 sheets, each having a table of 7 rows and 10 columns. Similarly, we can visualize a 1D array as a row of one row table having equal columns equal to the dimension. So when we declare an array 1D array as int ARR underscore 1 subscript 10, it can be visualized as a single row table having 10 columns. A 2D array can be visualized as a table with number of rows given in the first subscript and number of columns in the second subscript. So if we declare a float xyz subscript 10 and 15 as a 2D array, then it indicates that this array can be visualized as a table of 10 rows and 15 columns. How we see it pictorially? Int ARR subscript 2, subscript 5 and subscript 2 again declared and initialized here with int constants. So the element number 0 of this 3D array is a 2D array consisting of 5 1D arrays, and each 1D array has 2 elements, and we are initializing this 3D array with int constants. So int array ARR2 first subscript, it tells that there are 2 numbers of 2D arrays as the elements of this 3D array. 5 tells each 2D array has 5 elements of the 1D arrays, or 5 1D arrays as its elements, and another 2 third subscript, it tells that each 1D array has 2 elements as its 2 constants, int constant as its elements. So we can visualize it as a sheet number 0, where this 2D array can be visualized as a table. Then sheet number 1. So ARR 0 0 0 point to sheet 0, row 0 and column 0, which is 1 in this particular case. ARR 1 is this table, 4 is this row, and 1 is this constant 20. So ARR 1 subscript 1 subscript into 4 into third subscript 1 point to sheet 1, row 4 and column 1, which is 20 in this particular representation. So row 0, row 4, column 0, column 1. This is how we can visualize a 3D array. This visualization, it makes the imagination and treatment of the 3D array a bit easier. How 3D array is stored in the memory. We have already seen that 3D array is stored in contiguous memory locations. So this program, it demonstrates the memory locations which will be occupied by the constants of this 3D array. So we have declared a 3D array ARR with subscript 5, 5 and 2 as its elements. We have defined or we have assigned the initialization data to this array ARR. There are 5 2D arrays. This is 1, 2, 3, 4 and 5 2D arrays. Each 2D array has 5 1D arrays as its elements. So this is 1, 2, 3, 4, 5 1D arrays as its elements, and each 1D array has 2 elements. So 1, 2 are the 2 elements of the 1D array. Then we have declared 3 int variables I, j and k, and we have simply brought out addresses of 0th elements of each 2D array. So address of ARR subscript 0, 0, 0 is equal to %u and ampersand ARR subscript 0, 0, 0. What it does is it gives the address of the 0th element of this first or a 0th 2D array, which consists 0th element, which form the 0th element of the 3D array. Similarly, address of ARR subscript 1, 0, 0, it gives the base address of this element of the 3D array, and similarly for these 3 2D arrays, and these addresses are displayed, and the screenshot of the output screen I have copied here, pasted here. So the ARR 000 address is 65426, ARR 100 address is 65446, address of ARR 200 is 65466, and so on. And these 5 statements or the printf outputs tells us the values of ARR 000, which is 1, value of ARR 100 is 11, value of ARR 200 is 31, ARR 300 is 41, and ARR 400 is 51. So in this slide we are just look at the way the elements of the 3D array, which we discussed in the earlier slide, are organized or allotted memory locations by the compiler. So ARR 000 we have seen is allotted a location having address 65426, and then the subsequent values of 1 to 10, which we have assigned to the 0th element of the 3D array, are allotted memory locations in consecutive or contiguous locations. Then ARR 100 we are seeing, ARR 200, ARR 300, and ARR 400. So we can see that all the elements of the 3D array have been allotted consecutive memory locations by the compiler. So this is all about introduction to 3D arrays. In the next video we will be seeing how 3D arrays are accessed and how they are passed to the function, and how function returns the 3D array. Please subscribe to my channel and thanks for watching.